Okay, we're going to prove and apply properties about parallelograms. We're going to use properties of parallelograms to solve problems, and we are going to prove that a given quadrilateral is a parallelogram. Holy Hannah. So, first off, we know that a quadrilateral with two sides and parallel sides has to be a parallelogram. To write the name of a parallelogram, we can use this fun little symbol, or we can just write the word parallelogram ABCD. Okay, so let's look at some of these properties. We have a theorem that says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we know that this is a parallelogram because we already have opposite sides parallel. Okay, so if we have opposite sides parallel, then we can conclude that those opposite sides are also congruent. This is really powerful. We kind of guessed at this before, but we didn't know that it was true. Okay, next. If we know a quadrilateral is a parallelogram, then we know that its opposite angles are congruent. Okay, this comes from all of that work that we did in Unit 1. And we're not going to do this for every single one of them, but I want to just show you really quick that if you can imagine that these are my parallel lines, okay, and that these are my, like this is my transversal. Remember when we did those in like hot pink? Okay, these are alternate interiors, same side interiors, so they have to be supplementary, right? And then if you shift your focus and you make these two the parallel lines, and this one the transversal, I know it kind of hurts the brain a little bit. Now these two are the same side interior angles, and they have to be supplementary. Now, if the blue angles are both supplementary to the red angle, then they have to be congruent. Does that make sense to everybody? Because they have to add up to 80 with 180 with the red angle, so they have to be the same thing. Okay, perfect. So that comes from all of our Unit 1 stuff. Cool. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, we just talked about why that is. It's because of those parallel lines and the transversals. I feel like that one should have come first, but I didn't make this textbook that this came from. If a quadrilateral is a parallelogram, then its diagonals must bisect each other. Okay, do you guys remember what bisect means? Cut in half. Yep, it's the choppers and halfers. So if I have this fun little parallelogram, then I know that AZ is congruent to ZC, and my BZ is congruent to ZD. Okay, easy peasy. All right, cruising. We might get through a good chunk of this today. Well, it looked really intimidating, but now we're just like going on like gangbusters, so we'll see. Okay, in parallelogram CDEF, DE measures 74 millimeters. DE, 74 millimeters. DG is 31 millimeters. Okay, and the measure of angle FCD is 42 degrees. FCD, okay, so this one is 42. Okay, so we have to find CF, DF, and the measure of angle EFC.
CF is 74.
Okay, so CF is also 74, I agree. Because if this one is 74, then this one has to be 74. Because we know that it's a parallelogram. So, CF is 74 millimeters. Let's be good and write units. Okay, let's do DF. DF is this whole thing.
62.
Correct. So if this one's 31, this one is also 31 because that got bisected, right? So I know that this one is congruent to that one. So DF is 62 millimeters. Okay, the measure of EFC. Okay, that's the big angle. That's this one. So those are not opposite. They are consecutive. So what do our little theorems say about consecutive angles? They're either congruent or supplementary. I'll give you a hint. In a parallelogram. Supplementary. Write this down. Okay, so it's going to be 42 plus the measure of EFC equals 180. So what's 180 minus 42?
138.
Okay, measure of angle EFC is 138 degrees. That wasn't so bad. Good. Good.
Where do you get the consecutive angles or supplementary?
Okay, so here we have another parallelogram, KLMN. We know that LM is 28 inches.
So then those have each other's things.
Yes. Okay, we know that LN is 26 inches. So this whole thing is 26. And we know that the measure of LKN is 74. LKN is this guy. 74 degrees. Okay, find KN.
Who?
KN. Oh, we already did that. KN is 28 inches.
And LO would be half of 26.
Yes, LO is half of 26, which is
13.
13 inches. And the measure of angle NML. What is that one? 74 also, because these two are opposite. That's a little bit less work. Okay, so measure of angle NML. Is it easy, or did you just get that much smarter?
It's easier.
Okay.
I keep writing 47.
Okay, so we know that this is a parallelogram again. We have to find YZ.
We already found it.
It's right here. Okay, so if this is a parallelogram, then this one is congruent to that one. So what can I do with those two if they're equal to each other? Yeah, set them equal to each other and solve for A. So I know that 8A minus 4 has to be equal to 6A plus 10. So subtract away the 6A from both sides, and I get 2A minus 4 equals 10. Add the 4 to both sides, and I get 2A equals 14. So whichever one of you math wizards said that A was 7, you are correct.
It was Jason.
Okay, good job. Okay, but are we done?
No.
Okay, we still have to plug it in to find YZ. So we take the 7 and we're going to plug it in. So am I doing the right one? Yeah. So 8 times 7 minus 4. I was never good at my 7s.
7, 14, 21, 28. I don't know.
What is it?
56.
Is it 56?
Yeah.
Okay. What's
Yes.
56 minus 4?
52.
Okay, 52. Okay, so that is YZ. Let's label that. Okay, this is a measure, so it does not get a bar above it because we're talking about a length. Okay, let's put that in a box. Okay, what's the next thing we have to find? Woo! Okay, so unit 1 stuff. This might as well be a unit 1 problem. Okay, we got 2 parallel lines because we know that in a parallelogram our opposite sides are parallel. And I've already used hot pink, so I'm not going to do that again, but I am going to use blue. We have a blue transversal. So you see that these two are in the interior of our parallel lines, okay? And they are on the same side of our transversal. Okay, so we have same side interiors. Okay, they are also consecutive angles in this parallelogram. Both are correct ways to think about it. Either way, they are supplementary. So what do they have to add up to?
180.
Bingo. So 18b minus 11 plus 9b plus 2 has to add up to 180. All right, 18 and 9 make 27. B, we've got a negative and 11 and a positive 2. That's negative 9. Can I just move that over to the other side and make positive 9?
Yeah.
Okay, so that'll be 189 over here. And now what? Okay, divide by 27. What did you say it was? 7?
Yeah.
Okay, but we still have to plug it in. So this expression gives us the measure of angle Z. So I have to plug it into that. So the measure of angle Z is 9 times our 7 plus 2. Oh, what is with the 7s? 60 what?
63.
Okay, 63 plus 2. Thank you. The whole internet now is going to know that I don't know my 7s tables.
No.
It's fine. It's fine.
I can't see nothing.
It's because my big head's in the way. Did I tell you what my mom told me when I told her I was going to major in math?
Yeah.
She's like, you don't know your times tables. Turns out you don't need them. I mean, it helps, right? But like, if you can figure it out, you'll be fine.
I don't like circling.
You just need to know a couple and then be able to skip count pretty good. You'll be fine. All right, questions? Okay. Oh. All right, we got to find J, G, and FH. Ugh. Okay, that's J, G is this one. And FH is this whole thing. Which one do you guys want to do first? The purple one? Okay, so for the purple one, what we need to know is that this guy is congruent to that guy, right? Because the diagonals bisect each other.
Yeah, so it's equal to each other.
So we can set them equal to each other. Okay, subtract away the W from the right side and the left side.
Where'd you get the 3W? Oh, okay, I'm sorry.
I just read the picture. So 2W equals 8. I got 4.
Yeah.
So glad it's not 7. Okay, so now I just have to plug that in. So I know that JG equals 4 plus 8. I just plugged it in for that W right there.
Oh.
I'm getting 12. Okay, so for FH, we've got something a little bit similar. We've got something a lot of bit similar. So we know that these two are congruent because our diagonals are bisecting each other. So can't I just solve that for z the same way I did this other one? Set them equal to each other. So I've got 4z equals, no, minus, thank you, minus 9 equals 2z. Which side do you, I wrote x. Which side do you want the z's on?
Right. Yes.
On the right?
Yeah.
Okay. So we'll subtract away the 4z, and that gives us negative 9 equals negative 2z. Okay, divide both sides by negative 2. And I get 4.5 is my z. Now, before we just wanted half of a diagonal. Now we want the whole thing. So we can find one piece and then double it. Okay. So we'll just plug that in. Which one do you want to plug it into? We can plug it into both to make sure we did it right, to make sure that they're equal, and then just add them together. Okay. So let's do that. 4 times 4.5 minus 9. 4 times 4.5. Oh, is that 18 minus 9? Is that 9?
Your answer is 9.
Okay.
18 minus 9.
Yeah. 9. Okay, and then we'll make sure that 2 times z also gives us 9. So 2 times 4.5, that is also 9. So add them together, and FH is 18. Okay. Questions? Okay. Almost. Okay, here we have some beautiful conditions for parallelograms. No, this one's really long. Okay, so these conditions for a parallelogram are things that if we have them in a drawing or figure, we know that the figure is a parallelogram. So it's going to help us identify a parallelogram so that we can use all of the other properties of a parallelogram that we know. Like, if I can tell that my opposite sides are parallel and these are also congruent, then I'll be able to use, like, okay, my diagonals are going to have to bisect each other. Okay, I'll know all of that other stuff too. So if I have this, then I know all of the other goody stuff about parallelograms that I might use to solve problems. Okay. Another condition for parallelograms is that if I have both pairs of opposite sides congruent, then I have a parallelogram. So these two are congruent, those two are congruent, it's a parallelogram. I don't have to also know that they're parallel. Does that make sense?
Yes.
Okay, perfect. If both pairs of opposite angles of a quadrilateral are congruent, then we have a parallelogram. It has to be one. Cool, cool, cool. Okay. Here's another one. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then we have a parallelogram. Okay, we talked about this. Hey guys. Okay, for example, if this little guy is 60 and this one is 120 and this one is 120, you can see that 60 and 120 add up to 180. 60 and 120 add up to 180. If both pairs of consecutive angles are supplementary, we know it's a parallelogram. Good?
Yeah.
Okay. If the diagonals of a quadrilateral bisect each other, then we know it's a parallelogram. Cool. I believe that this table just summarizes the conditions from the other two tables, so we're not going to read it again. It's just a condensed version.
Oh, hello.
Okay. Okay, so these are tricky. You guys have your quadrilateral tree, right? So you know those 5 things, those 5 conditions for parallelograms? You notice that those are the same ones that are on here. I don't know why there are 6, but there might have been 6. I just said 5. There are 6. There are 6. I just said 5. Yes. Okay, so we have 6, not 5. I misspoke. So these are those same 6 conditions. Cool?
Yeah.
Okay, so I want you to use those so you're not flipping back and forth. Use your tree. Everybody should have the tree out.
This is obvious.
All right, is this a parallelogram?
Yes.
Why?
Because.
What do these add up to?
180.
Okay, these two add up to 180, and
So the other one's
these two add up to 180. So we have consecutive angles are supplementary. I want to draw your attention to the fact that this does say justify, so we can't just say yes, even though that's very tempting. So yes, this is a parallelogram. And then our justification is that our consecutive angles are supplementary. Okay, this next one is really tricky. When I first saw it earlier today, I panicked because I wasn't sure. Kind of got a little bit scared. So look at your tree. Does this meet any of those criteria? Look at your blue tree. Parallel sides?
Yeah. Or one pair.
We have one pair of parallel sides and one pair of congruent sides. So our conditions are, hey, put your phones away. Okay, we need both opposite pairs of sides to be parallel, or we need both opposite sides pairs to be congruent, or girls, we need one pair of opposite sides to be both parallel and congruent. And we don't actually have any of those. So this one is a no, and I will show you why. Okay, if I extend this parallel line, okay, and then I'm going to take this side, okay, everyone can see that I'm not doing any funny business, okay, and I'm going to rotate him a little bit. Okay, so I didn't change the length of that side. That length is still the same, so this side is still congruent to that one. But do you see that it can have two possible positions and these sides can still be parallel?
Oh, right.
Do you see it?
Yeah.
Okay, so this one is actually an O.
I don't know.
Okay, I think we can say that this is like a trapezoid, but we can't say that it's a parallelogram. So we're going to say no.
Why? Because it's not a parallelogram?
Because this side here can be the same length in this position or this position. We don't know anything about the lengths of these two parallel sides. So this side can be much longer. We don't know that this side is congruent to that side. We don't have that information. Cool?
Yep.
Okay. All right, let's look at C and D. C is a little intense. Okay, think back to our previous unit about triangles. What can I say about this shared side? It's congruent to itself. Okay, so if I use the reflexive property, I can say that it's congruent to itself. Okay, now do you all see that I have angle, angle, side?
Yep.
So I now have two congruent triangles. What do I know about the corresponding parts of congruent triangles? They are congruent, right? So I know that corresponding parts of congruent triangles are congruent. So now that I've shown that these triangles are congruent, I can say that this side is congruent to that side, and this side is congruent to that side, and voila, I have opposite sides of this parallelogram are congruent. Opposite sides are congruent. So that is our justification. So we can say yes. All right, what about this guy?
That looks just like. We're gonna say no.
Yeah. Okay, you're right. So look at your little descriptions of the different types of quadrilaterals. Put your phone away. What kind of quadrilateral is this if it's not a parallelogram?
Oh my. A trapezoid?
No.
A kite.
It is a kite. This is a kite. No, not a parallelogram. It's a kite. Okay. We have to show that quadrilateral JKLM is a parallelogram by using the definition of a parallelogram. So we need to plot these points. -1, -6. 1, 2, 3, 4, 5, 6. -4, -1. That was J. 1, 2, 3, 4, down 1. That's K. L is at 4, 5. 4, 2. And M is at 7, 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
You could grab something that's on the video.
Did I count that wrong? 1, 2, 3, 4, 5, 6, 7. I put it at 8. One, 2, 3, 4, 5, 6, 7. Count much? Okay, so what is the definition of a parallelogram? Yeah, both pairs of opposite sides are parallel. So how do we say that the sides are parallel? What do we need to know about the sides?
You need to find like the slope.
The slope. Okay, so let's find the slope. So what is my change in my y's? That looks like up 6 and right 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, that's 8. Okay, so we got one pair of parallel sides. Cha-ching, cha-ching. Now we got to do the other side. So I'm going to choose a color other than blue. Okay, so this is going down 5 and right 2, 3. 3. Okay, and this one is going down 3 and down 5 and right 3.
Yes.
So ta-da! Hey, and I forgot to label my vertices. Gosh, what was I doing? This was L and this was M. Okay.
You also forgot to put the parallel things.
I did. Oh, wait. Good thing you guys are so on top of it. Okay, so we know that J, K, L, M is a parallelogram. Because it's opposite, what? Yep. Opposite sides are parallel. Okay.
Oh, we know notes.
Okay, one more. So, theorem. Okay, this theorem 631 is the one that says one one pair of opposite sides is congruent and parallel. Okay, so that's what we're after. Let's plot these points. 2, 3 is our A. B is at 6, 2. 1, 2, 3, 4, 5, 6. Why is this so hard for me to see? B. C is at 5, 0. And D is at 1, 1. Okay. So, guys, which pair of opposite sides do you want to tackle?
Oh my gosh, why is there so much?
Spite.
There's like 4 pages.
And we're making it longer because we're whining. That's how it works.
No, I meant I'm on the homework.
Okay, here we go. So, which pair of opposite sides do you guys want to tackle?
Oh.
No. We just do one pair of opposite sides.
Okay.
AD?
Yeah.
Okay. So we're going to do AD and BC. Okay, perfect. One. This is the theorem. The theorem says that one pair of opposite sides are both congruent and parallel. Okay? So we only need to do one pair. Okay. So, as far as parallel goes, this one has a slope of 2. This one has a slope of 2. Easy. Done. Parallel. Check. Now we have to show that those sides are congruent. So we're going to make our little baby right triangle like we did yesterday. it has a length for a leg of 1 and another one of 2. So we can do 1 squared plus 2 squared equals our c squared. 1 squared is 1, 2 squared is 4. So I get 5 is our c squared. Then I have to do square root, 2 solutions, 1 positive, 1 negative. Do I want the negative one?
No.
No, I only want the positive one because we're talking about a length. So my c is root 5. Now, do you see that I would make the same little baby triangle right here, 1 and 2?
Yeah.
Okay, so that side, this one was AD, right? So we know that BC is also root 5. So they are equal, therefore AD is congruent to BC. Put segment bars over them. Check.